Well, you know this part. This is centered at x equals -2, and you know what's about to happen. Now, by this point, you probably got it. So I recommend that you mute the video, which I'm not going to say much on this one anyway, and try this one on your own. So here goes. 2 to the k plus 1, x plus 2 to the k, and x plus 2, because that's x plus 2 to the k plus 1. And then we have k plus 1 squared. And k squared goes here, and to the k, x plus 2 to the k. We have the limit as k approaches infinity of a whole bunch of stuff that's about to cancel out. That, and not as much canceled as I thought would cancel. Oh well, that's all right. That gives me k squared over k plus 1 squared, which means I need to create more space right here. I didn't leave myself enough space to write what I needed to write, which is 2 and then x plus 2. It's in the bars. And this component is equal to 1. Therefore, what I really have is 2x plus 4 less than 1. All right, well, as we do that, we're going to just keep solving. So we subtract 4 from all three sides. Feel free to do some of this in your head. Okay. You know your radius of convergence. If you don't know your radius of convergence, it's okay, actually. You're allowed to not know it, but you can figure it out pretty easily. Look at this. From -5/2 to -3/2, that's a diameter of 1. Well, half of that would be your radius of convergence. And you know it goes from -5/2 to -3/2. And we're going to see what happens at these specific x values. I'm kind of running out of room on my paper, but that's okay. We are going to plug in -5/2. We're going to do some of it in our head. So we are going to test x equals -5/2. And when we do, we're going to have the sum 1 to infinity of 2 to the k over k squared. -5/2 plus 2 is -1/2, and that is to the k power. It is legal for me to, let's do that, to somewhat factor this out, you could say. In a sense, we're factoring out this k. And we're going to really have 2 times -1/2. That's -1 to the k. So if you're wondering where that came from, that was, and I do want to write it up here just so you don't kind of get lost. This is really 2 times -1/2, and it was to the k power. That's where that came from. I'm somewhat factoring out the k from those numerators, that exponent of k. So this converges. And I know it converges because it passes the p-series test. It passes the p-series test. It's alternating, but I mean, you could pass the alternating series test and you got it. So there we go. We'll do the same thing with -3/2. When we do, we'll go quickly. So we're going to test x equals -3/2, and we have from 1 to infinity, 2 to the k. We plug in -3/2 right there. That gives us +1/2 to the k over k squared. We have the sum from 1 to infinity of 1 to the k, which is 1, over k squared. And that also converges. I didn't need the equal marks there. Converges because, well, p-series. There we go.